Hello and welcome to the computer science solution demonstration of Timetable Helper. Timetable Helper is a program that when supplied student declarations from an online questionnaire can aid creation of an IB timetable through holding data on the student declarations in a quickly accessible manner and also processing the data giving help when creating a timetable. Um, like I mentioned before, the program uses um, student declarations supplied from an online form. So I created a sample CSV file of the student declarations, which I created by sending out the online form to my classmates and they inputted some random data. Let's start the program itself. When you open the program, we are greeted with a graphical user interface in which the whole program is contained. The program is contained in one JavaFX scene which satisfies criterion B. Now let's load the student declarations. The student declarations are converted into student objects, and each student object holds all the requested data, um, the client, all the data the client requested. Um, so by loading the student declarations, we show that the user does not have to input the student data into the program. It is loaded for him, and um, C, the program holds the data on each student's last name, name, and so on. So that satisfies criterion C. Moving on to criterion D, the user can search for individual students and also subjects in criterion E. So let's search for students which last names start with G. Um, we get these two students. Um, or with B, we get these two students. Um, let's also search for some students that have computer science, that have chosen computer science. So we actually need to select subjects. Um, so these are the students that um, have chosen computer science. And how does it happen that we actually find those students just by inputting CO? Well, the input and all the strings we search for are converted to lowercase. And also the input is compared to the beginning uh, of the string we are comparing to. So computer science starts with CO, so CO matches CO, so we found all the students that have chosen computer science. Um, so that satisfies criterion D and E. Let's go to criterion F. The program shows which students have chosen unique subject pairs. For that, we need to generate the report. A lot of processes happen behind the scenes. A lot of things are calculated. And in marked students, we can see students that have chosen unique subject pairs. So this student has chosen a unique subject pair, biology HL and physics SL. No other student has this subject pair. So this is relevant when creating a timetable because this is the only student that stops us from putting biology HL and physics SL parallel in the timetable, and we might want to consult with the student if he or she does not want to change, for example, physics SL into some second choice subject. That satisfies criterion F. Let's move to criterion G. The program generates a table that the client requested. The table is supposed to be in both in PDF and CSV file formats. So let's open the PDF report, and that's the table the client requested. In a second, I'll explain how the table works. So this is just subjects against subjects, and the numbers are the amount of students have a given subject pair in common. So English BHL and Polish ASL. In the cell is written 8, so that means that 8 students have this subject pair. And when we have Polish ASL and Polish ASL, here is 8, it means that 8 students have Polish ASL. And when there is a blank, it means that no students have chosen this subject pair. We also need to have the CSV file format of the table. Um, this CSV file is really something we cannot deduce anything from, but we can input it into a spreadsheet program which will give us a table we've seen in the PDF file. Um, Now, moving on, we satisfy the criterion G. Let's move on to criterion H. The program visualizes which are the major subject choices. For that, I chose the pie chart because just by a quick glance, we can see that English BHL is the major subject where a lot of students have chosen it. Biology HL is a major subject. Math AISL is a major subject. This is relevant when creating a timetable because these are subject a lot of students have chosen. So we need to operate around those subjects when creating a timetable and not really try to change something with them. Now moving on to criterion I, the program generates a CSV report of possible triple subject combinations in a CSV file. So this is also in this folder, and this is this file. So this file gives us the possible triple subject combinations we could have run parallel in the timetable. So when we are starting to create a timetable, we could say that we want to run Polish AHL, English ASL, and Polish ASL parallel in the timetable because no students have those subjects in common. So everybody will be able to attend their subjects. So that satisfies criterion I, and for J, the program prevents the user from performing operations that are not possible. We already seen that here uh, we had protected one of the errors. This is also one of the errors we have to protect, where we cannot really search for both of these. So this is also error we have to protect, and it works. It is protected. So one major error would be when there is no declarations in the folder. So let's see what happens when we take out the declarations from the folder. Mm, let's load student declarations. Yes, there is an error and it's protected. Error, insert declaration file to declaration CSV folder. Similarly, when we click generate report, no student objects are found, so no calculations can be performed. And that satisfies criterion J. That's all the errors we had to protect. We satisfied all the criterions. That's the end of this demonstration. Thank you.